Hello, my name is Ruyun Huang and my project is tracking moving objects using Kalman filter. At first, there is a popular technology combining image processing, pattern classification, artificial intelligence, and automation science together. Yes, it is the tracking of moving objects. Tracking moving objects has widening applications in military guidance, security surveillance, intelligent traffic, weather analysis, and many other fields. My program here is successfully track the moving objects in a traffic radio using Kalman filter. I will implement the algorithm on MATLAB, and of course, I will use the Kalman filter method. Here is the introduction to Kalman filter. Assuming there is a discrete system that can be described as the following linear equation. Xk is equal to A multiply xk minus 1 plus wk. Here, x is the state variable and w is the noise of the system. And the second equation is the measurement of the system. Zk is the measured value at time k. V is the noise of the measurement system. Assuming that noise W and V are white Gaussian noise, hence their covariance matrices are Q and R. For all k and I, the covariance matrix between W and V is always equals to 0. Kalman filter will estimate the state variable by two steps. One is the time update equations. The other is measurement update equations. The first equation is the prediction of the state variable x at the next frame. And the P is the error covariance matrix. K in the first equation of measurement update equations is the Kalman gain. And the second equation shows the posterior estimate of state variable x based on the measured value z. And the P in the third equation is also the posterior estimate of the error covariance matrix. The process of the update equations will be repeated for the following images, and the posterior estimate from last process can be used as the prior estimate in current process. Is a recursive algorithm. The recursive process is as this figure, and the K prime and the P are the initial estimate. The basic program process is as following. First, the background images is needed to be pre-processed, and then initialize the Kalman filter. Next is the recursive process. First, reading one frame, detect and extract the object, then label the centroid of the object, and compute the time update and the measurement update equations of the Kalman filter, and then show the labeled image as the output. This is one step, then reading another frame. I use the traffic video under the MATLAB installation directory to test the tracking result. Since the program is dealing with images, I have to split the video into frames. Here shows some of my frames. First thing, I have to convert background into gray image and then implement the medium filter on it. At last, we can get the image at the right side is the gray image. The next step is detecting and extracting the moving objects. First thing, we need to do the subtracting the current frame by background images. Let's take frame 20 as the instance. The first image is the current frame and it subjects the background image. We can get a result of the subjection. And then we need to convert the result image into a binary image. In the binary image, we can see the object is divided into several white parts. And by morphological dilating operation, we can get one white part for the whole object, and this makes the computation simpler. The last step is to do the checking. We can get the image properties, which contains the centroid of the object, and then we compute the updated equations of the Kalman filter based on the centroid we just get. And here is the result of the equations. First is the prediction of the state variable x at the next frame, that is frame 21. And now we get the prediction for error covariance matrix P. This is the Kalman gain K we get from the measurement update equation. And that is the posterior estimate for error covariance matrix P. Here shows some checking results for different frames, frame 20, frame 32, and frame 19. The gray symbols on the cars are the centers of the moving objects. For conclusion, the whole process of checking moving objects using Kalman filter is as following. First, we detect the moving objects and extract the features of it. And then, as the features, we can compute the time update equation and measurement update equations of the Kalman filter. But here is some situations we will meet. First is a new object appears. Second is matching the target. Third is one object disappears. Now we gather all these informations and use them to update the Kalman filter. Here is a closed loop using estimates from last frame to improve the performance of current frame. Thank you. And at last, I will run a program on MATLAB to show a result. The white parts are the result of morphological dilating operations. And there are 120 frames in the video. And the green symbols are the center of the car. The last figure shows the positions of the objects ever appeared in the video. That's all. Thank you.